Dear parents, thank you for taking time to join us here at Unity Connects. The science curriculum seeks to nurture the students as an inquirer. The starting point is that children are curious and want to explore the things around them. The science curriculum leverages on and seeks to fuel this spirit of curiosity. At the end of the day, we want our students to enjoy science, value science as an important tool in helping them explore their natural and physical world, and be a stronger problem solver in their daily life. Through this workshop, parents, you will learn the strategies science teachers use in the classroom to teach answering of open-ended questions. Using questions from the various topics, science teacher will share the use of concept, connection, conclusion, the C3 answering technique to help students respond to such questions. In addition, the marking annotations used by teachers to mark the explained question will be shared to help you support your child in his or her inquiry journey. Let's start by understanding the open-ended question answering techniques. There are different types of questions in the open-ended section. Some can be answered using only one word, while others may require several sentences. You need to know how much detail to give in your answer. Writing more than what is required wastes precious time, while writing too little causes you to lose precious marks. Your child has been taught to pick up words in the question that indicate how they should be answered. For describe type of question, students are required to give relevant details about an object or event, but not required to explain their answer. For explain type questions, they are required to give reasons or making something clear and simple to understand, and we will make use of the C3 answering technique to do so. State type of question is the easiest and usually requires short answers without explanation. If the question asks for an interpretation of what the experiment tells you, students will need to interpret the results of the experiment. Another possible type of question will be asking for what would happen. In other words, we are asking the students to make a prediction. Again, no explanation will be required. Allow me to share with you some examples. This is a describe type of question. A farmer wants to find out if chicks will grow faster by eating corn or rice. Describe how he should carry out the experiment. The answer will be to write down the steps for the experiment as shown in the slides. No explanation is required in this answer. Here's another example of a question involving description. Karen pushed an inverted empty plastic cup in a container of water as shown in the diagram below. While the cup was in the water, Karen pierced a hole at the base of the cup. Describe what she will observe after that. To answer this question, students would simply describe that air bubbles will be seen coming out of the hole as water filled the cup. There is no need to explain why the bubbles are escaping from the hole. Next, this is a state type of question, which is the easiest type of questions that involve short answers. State the conditions necessary for germination. Students simply need to state down the conditions, which are the presence of water, oxygen, and warmth. Let's read the next type of question. What does this activity tell us? If object X is connected to the circuit and the bulb lights up, we can conclude that object X is a conductor of electricity. Again, explanation is not needed for this question. For questions that requires explanation, students will then have to make use of the C3 answering techniques, which stands for concept, connection, and conclusion. Under concept, students will recall what themes or topic the question is testing on. What concepts are being applied here? Students will then have to apply this concept to the questions by stating the evidence that relates to the concept from the diagram, tables, or graphs. What are the comparison made in the questions or the setups of the experiment. Students will then wrap up their answer by concluding the outcome or what happened as a result in the end. To put it simply, we state the concept being tested in the question, we use evidence from the question, and state a conclusion. In the next few slides, we will be sharing with you more examples of explanation questions and how your child can make use of his teacher's marking annotations to help himself or herself improve his or her answer.
Dear parents, this table shows the marking symbols teachers will be using to mark students' work. For spelling mistake, the teacher will underline the word and put a bracket. For missing C1, C2, C3, the teacher will put a caret to indicate where the missing component should be inserted. The teacher will then mark C1, C2, or C3 with a question mark and put a cross to indicate an incomplete answer. For wrong C1, C2, or C3, the teacher will underline what is wrong and mark C1, C2, or C3 with a cross. And lastly, for irrelevant answer, the teacher will mark the answer with a cross. In Term 2, the students will learn the diversity of materials and their properties. They will also learn how to choose the right materials to make an object based on the properties. The questions we will be looking at today will be related to the topic on materials. Let us look at the first question with the student's answer. Sally prepared 4 materials W, X, Y, and Z, which were of similar sizes. She soaked them into a bowl of water for 2 minutes, removed them, soaked off any droplets of water on their surfaces, and weighed them again. She recorded her findings in the table below. Give a reason why material Z is the most suitable for making an umbrella. The question requires the student to give a reason why material Z is the most suitable for making an umbrella based on the given table. From the table, the student has to study the data in the table carefully in order to answer the question correctly. In this question, the student wrote the mass of material Z after shaking off the water droplets is 23 grams. The answer given by the student is not correct, as the answer is missing both C1 and C2. The student is merely extracting the data from the table. There is no reason given why material Z is the most suitable for making an umbrella. In this question, the student has to interpret the data and apply his or her knowledge of the concept of waterproof as one of the properties needed to make an umbrella. In applying the C3 answering technique to answer the question, the answer is, for C1, material does not absorb water, hence no change in mass of material. Material Z does not show any change in mass before and after the contact with water. And C3 can be used to make an umbrella so the person using it will not get wet. Let us look at the second question with the student's answer. Nelson carried out an experiment to test how well each material A, B, C, and D can absorb water. Materials A, B, C, and D, which are of the same size and thickness, were immersed in a tray of colored water. The results of his experiments are shown in the diagram below. Based on the results of the experiments, which material A, B, C, or D is the most suitable for making a tower shown above? Explain your answer. The question requires the student to identify the material which is the most suitable for making a tower and provide an explanation for his or her choice. The student's answer is material B can absorb water. The answer given by the student is not correct, as the student had given the wrong C1. In addition, there is no evidence of C2 in the student's answer. The student is merely stating the answer from the stem of the question, which stated how well each material A, B, C, and D can absorb water. The correct answer is C1, material that can absorb water. C2, from the diagram, material B can absorb the most amount of water as the colored water rose to a highest level compared to the other materials. And C3, material B is the most suitable to make into a tower, so the person using it will be able to wipe himself dry. The student has to apply his or her knowledge of the concept of material being able to absorb water best is the one which shows the highest water level on it. In addition, the student has to indicate how this will allow the user of the tower to wipe his body dry. Let us look at the third question with the student's answer. Linda wanted to find out how well materials P, Q, R, and S will absorb water. She dipped the strips into 4 beakers, each containing 300 ml of water as shown below. Linda left the beakers on the table in the living room. Half an hour later, she removed the strips and the amount of water left in each beaker was recorded in the table below. Which material is most suitable to make into a bath tower? Give a reason for your choice. We can see that a similar concept can be applied to many different scenarios. For this question, it requires the student to identify the material from a table of data, which is the most suitable for making a tower, and provide an explanation for his or her choice. The student's answer is material Q. It can absorb water. The answer given by the student is not correct, as the student did not provide any evidence of C2 in the answer. The student had merely stated that material Q can absorb water. The correct answer is, for C1, material must be able to absorb water. For C2, material Q can absorb the most amount of water as it has the least amount of water left in the beaker. And C3, material Q is the most suitable to make into a tower, so the person using it will be able to wipe himself dry. The student has to apply his or her knowledge of the concept of material being able to absorb water best is the one which shows the least amount of water left in the beaker. In addition, the student has to indicate how this will allow the user of the towel to wipe his body dry. Let us look at the fourth question with the student's answer. Mr. Lim set up an experiment as shown below to test a physical property of two strings, string X and string Y. Both strings are of the same length. He added equal weights to both string X and string Y gradually and observed that string X broke first. Part A. What physical property of the two strings X and Y is tested in the experiment shown above? Part A is a state type of question, and hence a straightforward answer is expected. Mr. Lim then decided to choose one of the strings to make a fishing line as shown below. Part B. Which string X or Y is more suitable for making the fishing line? Give a reason for your answer. The answer given by the student is not correct, as the student had not used the correct concept or connection to the question. The student had merely stated that string Y can hold many fish, which doesn't show any comparison between string X and Y. The correct answer is, for C1, string Y must be strong. For C2, string Y is stronger than X because it can hold more weights before breaking. And for C3, string Y is more suitable to be used as a fishing line as it will not break easily. The student has to apply his or her knowledge of the concept of material, being able to understand the stem of the question to make a comparison between string X and Y. String Y has to be stronger, as it can hold more weights before breaking, and so it is more suitable to be made into a fishing line than string X, as it will not break as easily as string X. Thank you for joining me in this sharing session. We hope this sharing is beneficial in the answering techniques for science questions.